So before we get started here, basically what I'm doing today is a quick demo of continuous integration inside of Team Foundation Services. And as I've done this demo a couple times before I get started, I'm going to do a little cleanup, and that's what I was doing when I realized that the start time had slipped by. So let's go ahead and clean up the remnants of the last demo here. So let's see here. We go out to Azure. I deployed to Azure before, and I also have on the ProDataMan VisualStudio.com site a copy of this basic web app that we're going to deploy. I think I deployed it to Simple Web App, but let's double check here. I had created a team project out here for the purpose of doing this demo. I'm assuming it's Simple Web App. We'll go ahead and go with that. Let's double check here. We'll take a look at the build. When was the last time this build ran? 20 hours ago. Yeah, that sounds about right. Did this demo yesterday. So let's go ahead and delete this build definition. Delete that definition. CI Simple Web App is the name of that build definition. I might have a release out here, but we're not going to be using releases in this demo here. But okay, yeah, there's nothing there, so we'll go ahead and leave that. And then let's check our code. Make sure, yeah, it looks like we've got the Simple Web App as well as Simple Web App tests and the Simple Web App solution are floating around out here. And if we go into Visual Studio, check our team project here, Simple Web App, and let's look at his, actually, is the solution open still? No solution. Where is this workspace? Workspace is Demos, Basic MVC, Simple Web App. Okay, so let's go out to that location on C drive and clean up that folder. So in the C:demo folder, we have basic MVC demo, and then Simple Web App is what we want to get rid of there. All right. So let's see here. So we got rid of the build. Team project is still there. We're just going to access that team project and dump a brand new solution in it and then build a brand new build. So the workflow here, and I'll post this in a blog post with the link down below, but the workflow here, if we start completely from scratch, you know what, let's just do that. Let's start completely from scratch. See, nothing up my sleeves, no tricks. We're going to start a brand new team project. That'll make it easier than trying to back out here anyway. So back over in our ProDataMan Visual Studio online here. We're going to create a new project, and we'll call it Simple MVC App. All right, so new app, Simple MVC. We're going to store our source in Team Foundation Server, and we'll use the Agile process template. Even though this demo I'm mostly focusing on CI, maybe we'll drop a quick user story in there and a task or two. So go ahead and create that Simple MVC app. And I suppose the reality is you don't need to see my ugly mug while I'm doing this, but since I didn't introduce myself, my name is Antoine Victor, Scrum Master, Agile Coach, and various other things there. But really, I'm a developer, but doing more project management type stuff these days and Agile coaching. But I still like to write a little code every now and then. So today, kind of a combination of development methodologies, using the Agile process template, and continuous integration. So this is more of a kind of Agile project management or Agile project implementation type demo here. We're not going to be doing any real development or coding today. All right, like I said, you don't need to see my ugly mug while I'm doing this, so I'll just shrink down a little bit into the corner, and we'll get rid of this label here. We don't need to see that. And we will start off by creating our build. Now, creating the build won't really change anything right now. Nothing's going to be impacted until we actually finally deploy the solution that we're creating here. So I'm just creating the build just to kind of start the process here. So thus far, all we've done is create the team project online, and we're going to create a deployment build here. Now, our deployment build is going to be an Azure web app. In our simple MVC app team project, using that repository where we're going to eventually store our source code rather, into source control. And we're going to enable continuous integration because obviously for us to enable a deployment build, we have to have an automated build that we can then deploy to Azure. So continuous integration is kind of enabled by default there. We can't uncheck that checkbox. So we'll go ahead and create that. All right, now a couple basic things that we have to configure here. It's already looking for our solution with the .sln to restore any NuGet resources. Maybe we downloaded Entity Framework or something like that. We would then allow that to be automatically pulled down by NuGet. Let me get myself out of the way here so you don't have to try to look behind me while I'm illustrating the options here. Here for the solution, we have our build options, and again, because we told it that we want to do a deploy after this build, in the MS build arguments, we have deploy on build set to true. We have web publish method set to package. If we scroll over here to the right, we have package as single file set to true, and skip invalid configurations, true. And package location is set to our build artifact staging directory. That'll become important when we get down to the next step here, where we're looking at, actually not the next step, but the step after next, where we're looking at where we're going to publish, or what we're going to publish to Azure. Now, I'm running Visual Studio 2015, not 2017, so we're going to switch that. I'm not going to worry about doing a clean build at this point because we're creating a brand new solution, but if you wanted to make sure that your directory was clean every time you did your deploy, you may want to check that checkbox. All right, moving on to the next stage here. Here is where we're running our tests. Now, I'll go ahead and load the MVC default template and have it automatically add unit tests, which will give us tests for the home page, the About Us page, and I forget what the other page is that it gives us a test for. But basically, it'll give us 3 tests, and we can make sure that either those tests run successfully or that our build, or rather our gated check-in, fails. And since we have a few tests, I'd also like to see a code coverage report. You can see here that code coverage report is disabled by default. So we're going to go ahead and enable code coverage here by checking this checkbox. All right, now here is the important part here. We need to make sure that we have a Azure subscription associated so that we can make sure that we're deploying to the right location. Just playing around with zoom it here. So we're going to set the Azure subscription and the app service name. Once we select the subscription, it'll update the list of service names, and then we can choose that Azure deployment slot that we have out there already. So we're going to choose the MSDN platform subscription that we already have, and we'll authorize that subscription. And once that authorization is done, we'll be able to access the list of app services. So let's jump over here to Azure. Go look at our account here. Here in Azure, in our app service folder, we have basic MVC demo here. And let's see here, basic MVC demo. There's the URL for that. I'm just double checking to see if it's up. Yeah, so that's up from the demo that I did yesterday, but just FYI, here is the URL if you want to try this. Oops. If you want to try this out live after the demo or after I publish, basic mvcdemo.azurewebsites.net will be the URL. All right. So I'm going to actually delete that. And I'll just add it back in again. Just want to make sure it's clear that I'm not using an existing web app. We're going to create this whole thing from scratch, live radio style, just giving it a chance to delete. So again, the process here is we're creating, well, we've already created a Visual Studio Online team project, and we have our Azure app service that we're deploying into. I just wanted to make sure it was clean, cleared out, and not there. On the next demo, I'll show you how to provision these Azure services dynamically. For this demo, I just wanted to make sure that our environment that we're deploying to, that we're doing our continuous integration on, is there, set up, and ready to go. We're making sure that our build is there, and then we're going to check some code into source control, which will automatically deploy it out to this Azure website. So just making sure it's cleared out and set back up. In the next demo, we'll provision the app service dynamically as we generate the code. All right, so we don't need a SQL Server on the back end for this demo, so we're just going to do a web app. We'll recreate the web app. And basic MVC Demo was the name of our web app on our MSDN platform. We're going to use an existing resource group, default Web West, and our app service plan, we're going to use the free one that we already have out there, which is default 3. And then we're going to create our basic MVC demo Azure app service. Now that we've got that guy out there, hopefully we don't have to do a refresh. Oops, over here for our build. Let's just select it again just for kicks. Refresh our list. And there's our basic MVC demo that we just deleted and recreated that we're going to deploy to. All right, that's all we're going to change. Scrolling through to show you the rest of the options here. On publishing symbols, we can determine how, if we're going to skip, if it's indexed, what the artifact name is going to be. That's using a variable there, and how we want to deal with errors and other issues that arise. Then our drop directory, where those compiled binaries will finally end up. Over on options here, if the build fails, we want to make sure that we create a bug and assign that bug to the requester. Now, if you're not familiar with this process here, essentially the requester is the person that did the check-in into source control, which I'll illustrate for you. But again, this demo is primarily for the CI piece. So we're going to check some stuff into source control, but I'm not going to spend a lot of time building user stories and work items. See one of my previous demos on creating a team project and adding user stories and delivery team tasks. But for now, we're going to automatically create this bug task and assign it to the person that checked the code into source control if the build fails or if the test execution fails. Repository, that's been auto-selected for us, selecting from the drops directory. Variables, we aren't going to mess with any of the variables here, but we have the configuration settings here, determining whether it's debug, what configuration we're using here. Is it the release configuration, the debug configuration, or if we've created one, maybe a QA or testing configuration, and what type of CPU we want to build this for. And the build platform default here is set to any CPU, but we might change that to 32-bit or 64-bit CPUs if we're only supporting a 64-bit version of our software or only supporting 32-bit versions. And on the triggers, you remember when we created the build initially, because we chose a deployment build, the continuous integration trigger was checked by default, and there's nothing we could do about that. All right. Down here, though, gated check-in was not enabled by default, so we're going to go ahead and enable gated check-in. On the general tab here, nothing that we're going to change. On retention, again, nothing we're going to change, just determining the number of days that we're going to keep builds. And history, there shouldn't be anything in here because we haven't saved or executed this build yet. So let's go ahead and save our build, and we will call it CI triggered Azure deploy. Now, bear in mind, the deployment that we're doing here is not necessarily a deployment into production, but really what we're doing here is deploying into what would be theoretically a QA slot. So maybe we've got some QA testers out there that need to beat up on this resource and make sure that their manual and exploratory testing still goes well. Now, I'll talk about the different types of testing in a later demo, but for now, suffice it to say that just because we're doing continuous integration and we've automated a lot of unit tests, and maybe we've even automated some user interface testing, there's still a need for the QA team to do some manual testing, some exploratory testing, and maybe even some A/B testing out there with a small focus group or something. So there's still a need for that. All right, so we've got our build all queued up here. Let's go ahead and add our code. So in order to add our code, we are going to create a new project in Visual Studio, and from Visual Studio, we will check our newly created project into source control, which should fire off a build and dump it out into our Azure project. Doing a quick refresh here. Double check our Azure project and make sure that that site is not out there already. Check our app service. Basic MVC demo is running, but if we try to navigate to it, there shouldn't be anything interesting there. Okay, good. So that's where it was before, basic MVC demo.azurewebsites.net, but we deleted it, so now there is nothing there. Oops. So at this point, we'll jump into Visual Studio and we'll create a new project. So we're going to go File, New, Project. And we're going to create a basic ASP.NET application. And we will call it Simple MVC App. And we'll still leave that in the basic MVC Demo folder, Simple MVC App. We're going to create a folder for it, but at this point we're not going to add it to source control yet. We'll add it to source control manually from within Visual Studio so you can see how that works. And here we are in the template choices. So we chose MVC already. We're going to add folders to support MVC, and we're also going to add unit test for our project. I'm not going to worry about this host in the cloud, although if I did check this, it would give me the opportunity to choose which app service I want to deploy to for the purposes of deploying directly from Visual Studio. Now, I'm not going to allow that, or not going to choose that option, because I don't want you to get into the habit of deploying directly from Visual Studio. We want to rather check in from Visual Studio into source control, and then have a CI build and source control push it off for deployment into our QA environment. That way we keep our process in place. So we'll wait for our project to be created, and then we will add our project to source control. Okay, so here's our project, and we just need to add our project to source control. We'll do that by right-clicking on the solution and choosing Add Solution to Source Control. Let's see, we said we were going to use... Wait, it wasn't Simple Web App that we were going to use, was it? Sorry, got a little sidetracked there. What we want to do here is use our Simple MVC app that we just built. So we're going to go to the dashboard and open that in Visual Studio. That process forces the connection in Visual Studio to that team project in Visual Studio Online, or Team Foundation Services Online, if you will. Now here, it's defaulting to the Workspaces folder, but I'm actually going to change that folder and point to our C demos, basic MVC demo, and the Simple MVC app folder that we just created. Do a map and get, and then we'll simply open that project back up again. So now that our project is in the appropriate folder, we can add it to source control, and we automatically get the mapping since we already mapped the folder. And it shows us the little plus sign next to all of our files, telling us that we are ready to check into source control. Since checking into source control could, in theory, cause integration and build issues, we probably want to do our due diligence and make sure that our build succeeds locally. We want to at least be able to say, it worked on my machine. Right? So if we don't run the build locally, we can't even say it worked on my machine because we never tested it. So let's do that test real quick here and make sure it works on our machine. So we'll go ahead and run a build our solution. And building our solution has succeeded. And now let's run our tests. And all 3 of our tests succeed. So we know from a local perspective, at least, on our local developer's machine, that we were able to compile our solution with no build errors and run the tests. So at the very least, we know it works on my machine. Now, imagine, if you will, that there are other developers that maybe have worked on the solution and checked files in, and the checking in of those files may actually cause some integration issues. Now, obviously, nobody else is working on it because I just created it moments ago and haven't even checked it into source control. But we still want to make sure the build succeeds locally. So let's do a successful build, then we'll break some things. So we're going to check this into source control. And since we've already configured gated check-ins, when we attempt to do this check-in, it's going to tell us that you can't do a check-in because your build needs to be confirmed before we allow these changes to be checked into source control. So once our build succeeds, or if our build succeeds, then the system will go ahead and check our files in for us. So we go ahead and build those changes. And if we go to the Home tab of the Team Explorer, we can now go look at our Builds tab, and we see that our gated check-in is currently firing off a build. If we double-click on that, that'll take us back to the Visual Studio portal, the Team Foundation Services portal, where we can watch our build wait for an agent to host it. Now, as we wait for an agent to host our build, I'll slide over here to the other side. Once we see our build picked up by an agent, you can see it's in #1 position. It turned green there, so that just means that an agent accepted our build. And now our build is running. Rather, our build is not running yet. We're actually just getting the sources from source control. So getting all the code that we just checked into source control, that's being now pulled out over to our build server. I didn't use any NuGet resources, but the next step is where it would go out and look for those NuGet resources and add those with the source that we just downloaded from source control. And now with all that stuff combined, we go ahead and build our solution. Remember, we're looking for green. Green is good, red is bad. We want no red X's, only green check marks. So far, so good. Building, adding files. Build succeeded. Now we're running our 3 little tests. And as we saw the test succeed locally, the test should also succeed on the build server since nothing else has been changed. Our Azure deploy succeeded successfully. Succeeded successfully. Completed successfully. And our publish of the symbols and publishing of the artifacts into the drop directory finished successfully. We did our post-job cleanup and our gated check-in. Since it completed successfully, we're checking in those gated changes. So at this point, we should have a successfully deployed application to the URL that I shared with you earlier. So that means we should be able to go over here and do a refresh. And instead of getting this page, we should get that basic ASP.NET web application using the MVC template that we just saw. And there we have it. Ta-da! All right, so what we've done here is really basic. Obviously, we didn't change any of the code. We didn't make any major changes to the code here in Visual Studio. All we really did was create a web app and deploy that web app to an existing slot in Azure. So now what we're going to do, just to illustrate the use of gated check-ins, we're going to first break the build and the test, and then we'll try to check in. We'll see that the check-in fails because the build fails, and that keeps it from deploying to our website and breaking our website. And then we'll fix the build, but the test will still be failed. So we'll see that it still restricts our check-in and doesn't allow it to be deployed out to production. So this website, if you try to navigate to this website now, that should work just fine. But I'm going to break it, and while I'm playing around with our broken build, our production website should still be up and running. So let's try that. First thing we're going to do is go back to Visual Studio, and in Visual Studio we go into our solution and take a very quick peek. Let's see here at our test. So we have tests for our home controller here. And we've got a test here for our index, about, and contact. That was the third one I couldn't think of. Our index, about, and our contact pages. And let's see, let's just break the home page. So you'll be able to tell very easily if it's working or if it's not working. I'm going to do an assert.fail, just keeping it simple here. And home page is broken. It's going to be the message there, and then we'll just comment out this assert.is null. So this should cause our index page test to fail. Now, in addition to that, I want to break the actual build also. So in our home controller, we will also break the return by doing a return E before I. Return view. So now our build should fail as well as our tests. I'm not even going to check it on my local machine. In our shop, we call this the Tahoe effect. It's Thursday afternoon. The snow is awesome in Tahoe. So I'm not finished, but I'm done. I'm just going to check my code into source control and I'm out of here. I'm not going to check on my local machine and make sure it works or anything. I'm just going to right click and say check in, save, and off to Tahoe I go. All right, now because there's a gated check-in enabled here, it should warn me momentarily that my check-in, looks like we've got some conflicts here. Oh, because we made that change and it looks like our gated check-in hadn't completed successfully. So we're telling it to keep the two local files that we just changed and firing off our check-in again. And now it's prompting us for our gated check-in build. So again, I'm the developer that's trying to sneak off the Tahoe. I'm going to just say build my changes and then I'm out of here. So I'm in the car. I'm on my way to Tahoe, assuming this build takes longer than it takes for me to shut my laptop down and get to my car. But imagine, if you will, I'm in the car, I'm on my way to Tahoe, and other developers are trying to get work done, and we had no gated check-in. If we had no gated check-in, the changes that I just made would be allowed to be checked into source control. If I go home and we go look at our build, got that gated check-in in progress here. If we go and monitor that gated check-in, you can see here we're waiting. We're getting our position in the queue. The build agent is initializing. It's getting our files out of source control. Everything's going well so far. Files are there, nothing's wrong. Everything seems awesome. Getting all 0 of our NuGet packages. And then we build the solution. Or attempt to build the solution. Wah, wah, wah. Red bad. Green good, red bad. Build failed. And if we scroll up here in our console, we can see that our build failed because of what? Yep, there it is. The name VEIW does not exist in the current context. So it's telling us very clearly what the Visual Studio IDE already warned us of with a simple red squiggly. So we'd have to be a really bad developer to try to run off to Tahoe with something like this. So this is a compile error. Compile error is pretty easy to find. More likely than anything else, this compile error, or rather the errors that would cause these types of Tahoe effect issues, are integration issues where one developer changed something that another developer's code depends on. Now also, because that build failed, if we go back to the Team Explorer and we look under My Work, I can see that there's a new available work item here. Work item 235. Work item 235 is this failed build. We click on the failed build. It shows us it's the build that we were just watching. Okay, 97 seconds ago. So as a developer coming in, or rather, yeah, if I was the developer that checked this code in, then I tried to run off the Tahoe, my build didn't complete successfully, my changes weren't allowed to be kept in source control, they were kicked back out, and I now have a bug assigned to me. Two things. One, I'm reminded that I need to fix this bug, but two, now the entire team knows I checked in bad code and tried to sneak off the Tahoe. So, probably don't want to do that as a developer. So now that we've fixed our build, though, we want to attempt to check our changes back into source control. So we're going to check our changes into source control, save those changes, and we are going to associate those changes with the work item that was just assigned to us, work item number 235. We're going to resolve that with this check-in. It's telling us we have to gate our check-in again. So we'll do our gated check-in, and this time, again, if we go back and watch our build, the same thing will occur, except for this time, our build won't fail because the build has a problem. This time, our build will fail because we have a bad test, or rather, our test isn't passing. I guess technically our test isn't passing because it's a bad test. But in theory, our test could be not passing because the developer wrote bad code. All right, so here our agent is getting its stuff, getting the sources, getting our NuGet packages, building the solution, which should succeed this time. Nothing but green text over here. And then after we attempt to build our solution, we should get a failure on the test run. So there we go, green check mark on the build. But as we run our tests, we should still have that test failure. And there's our test failure. All right, so one last thing to do here before we can check our changes into source control. Last thing that we need to do is resolve our failing test, and then we should be able to check our code into source control, and we'll call this demo done. So back over in Visual Studio, in the Solution Explorer, we'll go and resolve our test issue by uncommenting the actual test and commenting our purposely failed test. Then we can save. And one more time, we'll check into source control, but not before going home and getting our work items. We've got a new one here, 236. So 235 and 236 work items are resolved by this check-in that we're about to do. So check in. 235. We're going to add 236 as well. And then we'll complete our check-in, which again should fire off our gated check-in. And this time, since everything is beautiful, we should not have any issues with our deployment. Now notice if we go look at the home page, while all this broken build was going on, nothing. Yeah, our build still, or our published site still works. Everything is still there, still working the way it's supposed to. So the failed build didn't affect our website. The failed test didn't affect our website. I guess I should have made some changes so you can see that the fix did affect our website. But let's watch our build run. Oops. Go look at builds. Our build should already be in progress by now. Yeah, there it is in progress. So I already got the sources, doing the NuGet. Our build of the solution should work. Nothing but green over here. And then because we've resolved our minor testing issues, our test should also succeed. So there's our successful build, running the tests. So far, so green. Couple seconds more. We should be good on our tests. There you go, green check mark on the tests. And now finally our deploy, which really, because I didn't change anything, we won't be able to tell any difference between what it looked like before and what it looks like now. So just take my word for it. The changes were successfully deployed. There's our green check mark on Azure App Service Deploy. Publishing symbols, dropping the artifacts into the drop directory, and then cleaning up all our files and finishing our gated check-in. So there you have it from beginning to end. A simple CI demo in Visual Studio Online or Team Foundation Services. Basically what we did here is we created a new team project, and then we dropped we dropped new code in that team project that we created, made some changes to that code, not really, and then we checked that code into source control, which fired off our automated build, and then that automated build allowed us to run automated tests. And once all the builds and tests succeeded, we finally deployed that solution out to Azure so our QA team can beat up on it and maybe run some load tests and stress tests and so forth. Although in reality we may want to run those load and stress tests on a different more production-like environment. In a future demo, we'll take you that extra step, and we'll deploy to a couple additional environments, and we'll even take it as far as to have some that we can associate with those initial check-ins. So for today, that's all we got for the live demo. Thanks for watching. My name's Antoine Victor. This is ProDataMan Trains. You can find the details for this demo, step-by-step instructions, on the ProDataMan blog at www.prodataman.com. Thanks for watching. Oh, don't forget to subscribe to our channel.